Cal, we are doing Chapter 1, Day 5, or Chapter 1, Section 5 in this video. We're looking at probably about a page and a half of review and a page and a half of brand new stuff. So I'll go kind of quickly through the review, and then I'll slow down considerably on the new stuff that I need to show you. All right, so we're looking at like applications of linear equations at first, and you're given this linear equation, and it's talking about the value of a car and time. So you've got this equation, and just to make it make a little more sense to you, I said you can kind of relate this to y equals, and then you can write it like this if you would rather see your slope and your y-intercept in the order in which you're seeing it. So it's similar to that, except switched around, and they're using function notation v for value of the car instead of y. All right, so find the slope, find the y-intercept. There you go, there you go. What do they mean? Well, the slope is, this is going to be the amount, the value of the car changes every year. So every year the car is losing $3,200 in value every year. And the y-intercept, that's $21,500. That was the beginning value of the car before it ever started losing any value. Okay. Domain and range. Interesting question. If you go back to what I showed you, I don't know, a couple days ago, domain and range, or domain. Let's just talk domain first. Ready? Two things you have to watch out for. One, don't let yourself divide by 0. 2, don't let yourself square root a negative. Well, you might look at this equation and say, I'm fine. I don't have any division. I don't have any radicals. My domain is all real numbers. True, but not in the context of this problem. Because this problem, x isn't just anything. X represents years. Like years that you've owned a car. So if you say your domain is all real numbers, do you really want me to plug in -10 for the number of years you've owned a car? I don't think so. I think the first number that I'm allowed to plug in for number of years I've owned a car would be 0. Okay? So I think my domain is going to start at 0. I'm allowed to plug in 0 for x. And when I plug in 0 for x, I know you know what I'll get for y, because this is the y-intercept. So when I plug in 0 for x, I get 21,500. Well, what else can I plug in for x? Can I plug in 1 for years that I've owned the car? Can I plug in 2? How about 3? How about 4? How about 10? Sure, I can own a car for 10 years. No, that's not going to work in this equation, because think about it. Let's start at 21,500. After the first year, let's knock off $3,200. Second year, $3,200 more. Third year, $3,200 more. Fourth year, fifth year, sixth year. Okay, now, seventh year, if I decrease by this amount 7 times, you know what my car's worth? $900. Okay, don't let that happen. So, watch out, you can only plug in x values up to 6. Because plugging in that 7th year is not going to work. It's going to give you a negative value for your car. So, in the context of this problem, you may only plug in values anywhere from 0 to 6, including, see the brackets, 0 and 6. Now, range is, okay, when I plug in any of these numbers, what am I going to get as my y's? What are my y's going to look like in this function? So, I tried it. Plug in 0, you get 21,500. Plug in 6, you get 2,300. That's your range. Write it properly. So low number, high number. Yes, it can equal those two amounts. All right, next problem. Similar, but you have to write the equation. So it's telling you that this is a yacht that's being filled with diesel. Diesel fuel. So let's see. It starts out with 500 gallons, and we're going to put more in it. So it starts with 500, and we put it in it, we squeeze the handle, and it's flowing in at a rate of 40 gallons per minute. So, write a function. I wrote the function. The amount of diesel is equal to the starting amount plus 40 gallons each minute. D of 30, plugged it in, got it. What's it mean? Well, it's how many gallons are in the tank after I've been fueling for 30 minutes. So we started at 500. After 30 minutes, we now have 1,700. Find the time. My answer should be T equals. Find the time to fill it up. So this is the amount of diesel that it's going to take to fill it up. How long will that take? Excuse me. So I plugged in the total amount of diesel right here for D equals, here's my equation, and then I just solved for T. It's going to take 48.5 minutes to fill it up all the way. We started with 500. It's going to take this long to fill it up all the way. Domain. Well, again, if you look at the equation, it looks linear. What can you plug in for T? Oh, I can plug in anything. No, not in the context of this problem, you can't. So be careful what you plug in for T. T is time. We don't want to plug in negative numbers. And don't plug in an outrageous number because don't plug in like 100 minutes because that means you're going to be standing there for 100 minutes and the gas is going to be overflowing. So, domain. Start with a time of 0. And then how long can you stand there holding the pump, filling it up? Well, until it's full. And we figured out how long that would take. That would take 48.5 minutes to get it full. So, at time 0, it has 500. And after this amount of time, that's how much it has. So, beginning amount of diesel, ending amount of diesel. Again, if I went through any of this too quickly, pause it, copy it, rewind it, listen to it again. All right, for the next one, we're supposed to take this information and write a linear equation out of it. Now, there's not much space here to do this, so bear with me. It says write a linear equation, and instead of using x and y, it wants us to use function notation, E of t and t. So, you all know that you can do this. This is what your y looks like in function notation. So this must be kind of like my x. All right? And it says x is the number of years since 1960, and E is life expectancy. So you've got to be so careful when you go to make your ordered pairs. Make sure your x comes first and your y comes second. Okay? Make sure it's in this order. How does that relate to this problem? Well, make sure that t, your time, goes here, and E, your life expectancy, goes here. Do not get those backwards. It's so important. And you shouldn't get them backwards because it tells you what each one of them represents, okay? I know you can make that connection. So make sure this is the way you set up your points. Okay, so this is the way I'm going to set up my points. Now, if I go to this information right here, and I grab that information and turn it into points, These two data pieces go together. This is year, this is life expectancy. They go together. I'm going to make an ordered pair out of them. This is year, this is life expectancy. They go together. I'm going to make an ordered pair out of them. So if I write 1970 and 74.7, looks like this. And for the other one, 2000 and 79.7, looks like this. This is good. This is set up well, but wait. This problem wants you to change it so your numbers aren't outrageously big. So it says, hold on a minute. Yes, you're set up correctly, but when you're looking at time, that first number in your ordered pair, don't put the year. Put the number of years since 1960. So instead of writing the year 1970, I'm going to write 10 because that's 10 years since 1960. And instead of writing 2000, I'm going to write 40 because that's 40 years since the year 1960. These are the points you want to use in your problem so that your numbers don't get out of hand and they're not too big. Now, important note, especially when you're doing My Math Lab, when you're taking a test. If it doesn't tell you to do this, don't do it. So if it just says use the years for time, then use the years for time and you're going to have big numbers. If you do it on your own and you're like, I don't want to use big numbers. I'm going to make my years since 1950 or whatever. No, you're going to get it wrong. Only do this if it tells you to do this. All right, so I've got 2 points. I'm working on writing a linear equation. I don't really think I need to go over this, do I? I'm going to find the slope. It's kind of yucky, but I used my calculator. I'm going to write an equation. Oh, hey. At the very end, I made sure to follow directions because it said, let's use function notation. Let's use e of t in place of y. And let's use t in place of x. So I did. I took my answer, which I liked it. It looked good. I felt good about it. And it said, nah, let's put it in function notation and let's use these variables. So I did, and then I circled my answer. The next part, use the equation that I just made, the pink one. Use the equation to predict E, life expectancy, in the year 2020. So in the year 2020, I'm going to use the number 60. That's how long it's been since 1960. So I plug in 60, and there you go, life expectancy in the year 2020. That's funny. In a morbid sort of way, if you think about what's going on in the year 2020. Anyway, we'll move on. All right. Okay, here's the new stuff. Now, it's new. It's wordy. The picture's going to look confusing. I promise you the math is easy. Like, I promise. The math is going to be easy. Before I show you the easy math, I just kind of want to explain what's going on in this problem. 2 reasons. One is, this is a great lead-in to the not quite as easy stuff that we're getting ready to do in a minute. So it's a great lead-in. I kind of want you to understand it. Also, the other reason I want to go over this is, for those of you that are going on to calculus, like, this is the day before day 1 of calculus. So like we'll be in calculus class for a couple of weeks, but we're not really doing calculus yet. And right before I start teaching them calculus, this is what we do. It's a great lead into calculus. So if I can get you to kind of understand on a pre-cal level, you're just that much ahead of the game when you go into calculus next year. Okay, but again, don't get freaked out because I mentioned calculus class. It's not that difficult. So I'm going to show you the picture, and I know the picture looks confusing, but let's say that there is a blue function, okay? And it's called f of x. And I've kind of like pointed out two specific points on that function. I have a pink point and a green point. And I tell you, look at the pink point, look at the green point. Tell me, how did the blue function change from the pink point to the green point? How did it change? You should probably say something like, well, from here to here, the blue function went up some and then came back down. Yes, it did. But I'll say, okay, that's good. But overall, like don't even get that specific. Overall, what happened from pink to green? Overall, like on average. What happened from pink to green? You could say, well, from the pink point to the green point, overall, the blue function only went up that much. The blue function only went up that much from here to here. Not here to here, but from here to here. So the blue function went up that much. You know what that is? From this y level to this y level, that's the change in y. For average rate of change, how much did y change when you compare it to how much x changed? Because from here to here, that's how much x changed. So on average, you can say the y's changed this amount and the x's changed this amount. Yes? That's slope. Change in y, compare it to change in x. What do you know about slope? Here's what you know about slope. Give me that point, I'll do my slope formula. Okay, let's do it. Now, we have to go and complicate things by calling it not slope. We're calling it average rate of change. So, blue function, what was the average rate of change? So here's what I need you to do. In your homework, in your notes, in your homework, on your test, you're going to have to find the average rate of change. It's going to say, find the average rate of change. So what I need you to do is I need you to lock this correlation into your brain. So I want you to like highlight or put a cloud around average rate of change and out to the side write slope. Right now. Do it. Cloud, slope. Got it? Keep going. Everywhere you see average rate of change, cloud it, write slope. Cloud it, write slope. In fact, pause the video. For the rest of the page, it should happen 5 times. Cloud, average rate of change, and write slope. Now, here is a formula to find average rate of change. Wait, why do you need a formula to find average rate of change if it's just slope? You don't. Your formula, now look, this is in function notation. Not a big deal. It's your second y minus your first y. But it's function notation. y2 minus y1 over x2 minus x1. It's just slope. Average rate of change is just slope. So, if I give you a pink point and a green point, can you all do the slope for me? Told you the math was going to be easy. ready? Here we go. Find the slope. Here's what the function looks like. So this is like the equation of the blue function. Well, maybe not this one, but whatever. Here's an equation of a function. Find the slope from the pink point to the green point. Slight problem. Can you see what the problem is? Slight problem. I know if I give you the coordinates of the pink point and the coordinates of the green point, you can do slope. Didn't I give you the coordinates of the pink point and the green point? Well, not exactly. I gave you only the x of the pink point. And I gave you only the green. No, only the x for the green point. I left out the y values. And you need those y values to do your slope, don't you? You need y2 minus y1 over x2 minus x1. I didn't give them to you. Now, at this point, some of you are like, oh my gosh, I know what to do. You just plug them in the equation. Yeah. Find your own y's. Like, I'm going to give you everything. Find your own y's. Plug in your x. Get your own y. Plug in your x. Get your own y. So I did. I showed you where I took my pink x value, I plugged it in my equation, I got my y. So my pink point is actually -1, 3. And then I took my green x and I plugged it in my function and I got 8 for my y value. So my green point is actually 4, 8. Now do slope. Told you it was going to be easy. It's just slope. The only tricky part, and it's just a tiny bit tricky, it's just slope. The only tricky part is I didn't give you your y values. You have to come up with those on your own, which is totally doable. You can do that. Average rate of change is slope. Lock that in your head. Okay, now here's what I want to do. Before we move on to the back page, remember this picture? I sort of duplicated it on another sheet. So let me go over it. You just kind of kick back, put your pencil down, just listen. When I'm finished with my new drawing, if you want to copy that down, you can. You don't need to. It doesn't need to be in your notes, but whatever. I'll leave that up to you. So here we go. Skipping, new page. All right, so my equation looks a little different, or my graph looks a little different, whatever. Here's what we've got. We have got this pretty curvy blue function, okay? And I have pointed out 2 points on the function. I called my pink point P and my green point Q. It doesn't really matter what I named them. There's a pink point and a green point. What do you think I'm going to ask you to do with the pink point and the green point? I'm going to ask you to find slope between pink point and green point. But I haven't given you the function equation. I haven't given you an x to plug in, like an actual number. I haven't given you any of that. So, hang on, I lost my y-axis. Let me put my y-axis back up there. Y-axis. There we go, that makes me feel better. Okay. I want to write an ordered pair for the pink point. What do I write? Well, how do you get to the pink point? You have to go over this amount. What are we going to call the amount from here to here? Gee, I think I'll call it X. Make it a little bit bigger. Okay? So for my pink point, I go over this amount. How far do I go up? Well, I don't know. Plug X into your equation and find out. Seems weird, I know. Plug X into F, and what does it look like? It's not a trick question, it's so easy. Plug X into F, you know what it looks like? It looks like this. Right? This is your X, this is your Y for the pink point. I know it's a little vague and there are no numbers and that kind of freaks you out, but it's okay. This is your X, plug it in, this represents your Y. All right. Now, let's go over to Q. I'm not going to tell you what this is. But here's what I'm going to say. I'm going to say, starting here, scoot over on your x-axis. Start here. Scoot over some amount. Scoot over some amount. You're probably wondering, well, how much are you supposed to scoot over? I don't know. I don't care. Let's call it H. Ready? What's this? What do I put down here? Don't tell me like 10 or 15 or anything like that. Well, how far over am I from the origin? That far? No. That's just X. We scooted over. So we went this far plus more. How much more? H. Now I think you know what to write here. So right here, you're going to label this X plus H. I know, now some of you are wanting to call this like 5, and you want to call this like 30. No. This distance is X. We scooted over the amount of H, which makes this label X plus H. So, in my green ordered pair, here's what it looks like. Ready? X plus H, comma. Whew. Now, how do we get all the way up to Q? Whatever this is, plug it into your function to get your Y. That's what we did here. We plugged this in to get our Y. So let's take this, yucky as it seems, let's take this, let's plug it into our blue function to get our Y value. What does that look like? What does it look like when I plug X plus H into F? Here's what it looks like. Plug it in. Now, I know that probably looks super yucky to you. You're like, why can't you just give me 2 points? Well, I'll tell you why in just a minute. So this is our pink point, this amount up that Y amount. This is our green point. We go over this far plug that in to get our y. Now, as yucky as this sounds, do slow. Do slow. From pink to green. We got our x, comma, y. We've got our x, comma, y. Do slow. Here's what it's going to look like. y2. Hang on. Slow equals big fraction. Okay, here we go. Ready? y2. So go to my green point and grab whatever I wrote for y. y2 minus y1 over x2 minus x1. This one minus this one. Okay, there's not a whole lot that can be done here except something plus h minus something. X plus h minus x. Well, wouldn't the x's cancel out if you collected like terms? So we're left with slope, average rate of change, equals that minus that over all that's left is h. Why on earth would you do that, you say? Well, in calculus, we want to be able to do average rate of change for any function starting at any point and scooting over any amount. Any function, any point, scoot over any amount. That's why it's so vague. That's why I didn't let you use numbers. And we end up with this. And now, this has another name for it. It's called the difference quotient. So, if you keep your video pulled up right here, and then take your paper notes, and you look at the third page, you're going to see compute the difference quotient. This is what we're going to do for this particular function. Okay? It's going to take a little bit. It's going to take a little bit of time. It's going to take a little bit of algebra skills, but that's what we're getting ready to do. So, first of all, don't freak out. You do not have to memorize the difference quotient. It's going to be given to you every time you need it. So it's either going to be in your notes for you to use on your homework, on your test, it's going to be given to you. Here's the difference quotient. Do it for this problem. That's what we're about to do. So I am going to scroll back up, and here we go. Ready? Oh, also, got to be really careful. So this progression here up at the top, this is exactly what I just showed you, except it's not color-coded. So I did this first, and then I collected like, actually I did this one. I didn't do the parentheses. I did this one, I collected like terms, and I did this one. Okay. You got to be careful in this problem that you don't do any illegal canceling, because if you cancel illegally, what we say typically in our pre-cal classes is you kill a kitten. If you cancel illegally, you kill a kitten. And some of y'all like get really carried away with canceling. So here's what, a little dramatic here, but this is what some of you are going to do. You're going to be like, oh, look, those H's cancel, and oh, look, the X's cancel. Oh, look, these X's cancel. Oh, shoot, I have minus signs. I think I'm going to cancel the minus signs. All that leaves me is 2F. Whoop, there's my answer. All that illegal canceling, we just killed 1, 2, 3, 4. We killed 4 kittens. You got to be careful. Don't just cross stuff out just because you see it on the top and the bottom. All right, let me get rid of that. So Nobody says, well, Mrs. Neal did that in her notes. No, I didn't. All right. It says, ready? Here's your function. Do the difference quotient. Now, I've kind of changed colors a little bit, but basically, here's what we're going to do. This is what my function looks like with x plugged in. This is what I'm supposed to do. Right here in this blue cloud, I need my function with x plugged in. That's easy. I've got it. It's over there. We've got that. Red cloud, a little bit tougher. I need my function, which is up there, over there. I need my function, but I need this plugged in it. Ooh, holy moly. That's going to take a little bit of skill, okay? So I'm going to switch to red, and we're just going to work on, let's look at what our function looks like with this plugged in it. So here's the original. That's what it looks like with x plugged in it. Let's, instead of plugging in x, let's plug in x plus h. So everywhere you see an x, here, here, and here, you know what we're going to plug in? X plus h. So like, remove the x and put this in its place. Watch, here's what it's going to look like. Pay close attention. People tend to mess this up. Complete substitution. I'm going to put this in place of this. Keep it going. Can you see how I put x plus h in this spot, and right here I put x plus h? Okay, now we have some algebra to do. So we need to work on simplifying this. So the first thing I need you to do is I need you to square this binomial. Yep, I need you to FOIL. Here's what we get. Actually, I'm just going to keep my equation going. Ready? So this is what I'm about to do. I'm about to FOIL this out. So I'm going to go first, x squared. Outer, x times h. Inner, h times x. Last, h squared. Y'all see what I did there? I FOILed this out. So I did first, outer, inner, last. Now let's keep it going. Now I'm at the plus sign. So I'm going to go plus. Now I'm going to distribute my 3 into that set of parentheses. And don't forget the minus 1 on the end. So, when I plug in x plus h, this is what it looks like, and it's a super humongous mess. The only thing I can do is I can collect these two terms. So one of these and one of these makes 2 of these. So I've got x squared. I've got 2 of these hx's. I've got an h squared. I've got a 3x. I've got a 3h. And I've got a minus 1. All that is what f looks like when I plug in x plus h. This red cloud represents this. Okay? Oh, we are so not through with this problem. So, now, this is what I'm supposed to be doing. Red cloud, I got it. It's ugly, but I got it. Blue cloud, I got it. It's up there. Let's do that fraction. Okay, and it's called the difference quotient. So I guess I'm just going to label it like difference quotient. Ready? Difference quotient equals. It's going to be a humongous fraction. And it starts out with the red cloud. So go down here and grab the red cloud and write it. In fact, I'll write it in red. It looks like this. X squared plus 2hx plus h squared minus 1. What comes after the red cloud? A minus sign. What comes after the minus sign? Everything in the blue cloud. Everything in the blue cloud gets subtracted. So, watch. What do you think? Did I do it right? Red cloud minus everything in the blue cloud? Oh no, I didn't subtract everything in the blue cloud. I only subtracted the first term. You know what needs to happen. You need parentheses around that blue cloud. Okay, and then all over h. Don't forget about that. It's a fraction. It needs an h on the bottom. Whew. Let's simplify. Ready? All I'm doing right now is I'm distributing that negative into the blue cloud. So I get negative x squared, I get minus 3x, and I get a plus 1. And it's all still over h. Don't be lazy and get rid of the h. The only thing I'm going to allow you to be lazy on is you don't have to write the left side every single time. Okay, now what can be done here? Oh, we can do some stuff. Look at the top. Are there any terms like terms you can collect? Heck yeah. Positive x squared, negative x squared. They collect and they're gone. All right. How about this one? Anything? No. How about this one? Anything? No. How about this one? Anything? Yes. Positive 3x minus 3x. Collect like terms and they're gone. Where are we? Here, here. How about here? No. How about here? Oh yeah. Negative 1, positive 1. Collect them. Gone. All right. Let's kind of reevaluate. Where are we? We still have a 2, an h, and an x. We still have an h squared. Gone. We still have a 3h. Gone, 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 gone. All over h. Whew, we're getting there. And I know you're kind of wanting to cancel out some h's, but let me make sure that you know how to do it legally. So this term has an h, this term has an h, this term has an h. Factor it out. Right? Factored out the h from here, that's what's left. From here, that's what's left. And from here, that's what's left. These cancel. Not these. This is going to kill kitten because this is part of a trinomial. This is attached to my parentheses with multiplication. This is legal to cancel. And my final answer to my difference quotient is 2x plus h plus 3. Reminder, you don't have to memorize this. This is what your function looks like with x plugged in. It's up to you to use it here. And don't forget to put parentheses around it. It's also up to you to somewhere over to the side, come over here and write out what does your function look like with x plus h plugged in it. And you've got some work to do. You might want to put a colored cloud around it and make sure this gets inserted right here. And then be careful on your collecting, be careful on your canceling so that you don't kill a kitten. All right, hope that goes well. Average rate of change equals slope. Block that in your head.